Hello, everybody. Today we are talking about 3-5, which is interpreting qualitative graphs. And I'm not looking at your workbook today, so we are looking at 3-5 in your workbook. So make sure that you're turning there to example 1. You should see a train. So let's begin by showing the video.
How does a qualitative graph describe the relationship between quantities? Think about this question during the lesson.
Go to the top of your page, circle that. This is the essential question. Many of us might not understand really what a qualitative graph is yet, but that's what we're going to be talking about today.
An express train reaches its travel speed of 150 miles per hour shortly after leaving the station and travels at this speed for an extended period of time. What would a qualitative graph of the distance the train travels over time look like once the express train reaches its travel speed? What is the relationship between time and distance?
So think about this on a train. How many of you have seen trains start and progress to speed? Is it instantaneous? Think about a car. Do you just go from 0 to 60 like right off the bat? If this train is going from 0 to 150 miles an hour, how long is it going to take? Is that rate going to be constant all the way through? Is it going to be going 150 miles every hour? Or in the incremental times, is it going to take a little bit of time for that engine to start going? And then till it's starting to go faster, 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 till it gets up to the speed. So that's what it's talking about. It's not talking about exact numbers. It's thinking about something in its relationship of real life. It doesn't automatically start going. There is a slower time before it actually starts going 150 miles an hour.
We can draw a qualitative graph. It's a little different from the graphs you've drawn before. A qualitative graph represents the relationship between quantities without numbers. You begin by identifying the input variable, which is time, and the output variable, which is distance. We also need to identify the intervals. An interval is the period of time between 2 points of time or events. The first interval on the graph begins with the train standing still and ends when it reaches travel speed. The second starts when the train reaches its travel speed. In which interval will the graph be steeper?
Select your answer.
So that's what I was talking about. In the very first interval, that train is just getting the momentum, right? So in that interval, that small portion of time where it's just starting, it's just kind of getting the wheels moving, it's just starting to move all of that weight forward, it's going slower versus when it's at speed, when it hits 150 miles an hour. So which interval will be steeper? Steepness means like if you're going up a hill, the steeper it is, the harder it is to climb because the more vertical takes more effort. So the steeper it is, the faster the rate is going. So let's see. No, because it's going at a slower rate.
Now let's determine the relationship between the two variables during each interval. At the beginning of the first interval, the time and distance are both 0. The express train starts moving at a speed less than the travel speed. The distance increases as the time increases. The second interval starts when the train reaches its travel speed of 150 miles per hour shortly after leaving the station. The distance continues to increase as the time increases. Since the train is traveling faster in the second interval, the graph is steeper in this interval.
So in both of these intervals, we're always reading time or a graph from left to right. So when we read this graph from left to right, it's always talking about what is the graph doing from here to here. So it's increasing, but it's increasing slow. Write it. Here, it's increasing fast. Wow, I can write like a 5-year-old child. There we go. Increase fast. So it is steeper.
As time increases, the distance the train has traveled increases. The function is increasing in this interval. Once the express train reaches its travel speed, a qualitative graph of the distance the train travels over time is a straight line. Now you know how a qualitative graph can describe the relationship between quantities.
So let's see if we really do. Pause the video and do the try it. So the graph shows another interval in the train's travel, which best describes the behavior of the train in this interval. Well, in this interval, what do you think is happening? If we're reading this graph right here from left to right, what's happening? Turn to your partner. What's going on with this train for the graph to be going like this? The speed is decreasing, so what do we think is happening? Yeah, it's got to be stopping. So as time increases, as time goes on, it increases. The speed of the train decreases. The function is decreasing. There's 3 words that you need to think about in the next day or two, actually next few days. Where's my pen? We are going to have increasing. We are going to have decreasing. And we're going to have constant. Okay, these are the 3 words that you're going to be thinking, and we're always reading graphs from left to right.
The graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval.
So again, we have 3 words: increase, decrease, and constant. So in interval 1, where dude is kicking the ball, again, we're moving from left to right. So he's starting here. What's happening to the graph? Is it increasing or decreasing? It's increase. Interval 2, What's happening? From here to here, after it hits its highest point, it starts the drop. So it's not really talking about slopes. It's not talking about a constant rate. It's just what is happening to the graph. Is the graph increasing? Is it decreasing? That is all we're talking about today. We still haven't seen anything with a constant, but what would a constant be like? Think about that, because we're going to get there in just a little bit. So here in this graph, well,
The graph shows the behavior of Skyla's skateboarding at a skateboard park. In which interval is the function increasing, decreasing, and constant?
so I ask about constant. Where would it be constant? Well, as time goes on, her distance above ground in meters, so the height that she is on the skateboard, from here, she was starting off maybe on a ramp, and then she went down the ramp, and then her height above the ground here remained constant. So that's where our constant is. So that 2 part is constant. So intervals, whenever we're increasing, which numbers are increasing if we are reading always from left to right? That's the logic and the consistency in math. We're always reading graphs left to right. So 1 starts here and in here. 2 is kind of in this constant range, and 3 starts here and ends here, and then 4 starts here and ends there. So which one are increasing? Which one is decreasing? We have 2 here. We have 1 and 4 because from here to here is moving downwards. And 4 from here to here, it keeps moving downwards. So 1 and 4. And constant is 2. It has this flat surface right here. So in example 3, it's which intervals in this function is increasing, decreasing, and constant. So again, right on the bottom of your graph, because we need to always know that we're reading from left to right, because that matters. If we switch directions, different things will increase versus decrease. If we were starting over on this side and moving this way, the lines that are increasing and decreasing would be different. Constant would stay the same. So if we just start at here, interval 1 is increasing. It's starting at 0 and it's moving up. So as time moves, it's increasing fairly fast. So that's got a very fast speed. It's not getting higher, it's increasing its distance. So as time moves on, it's getting further along. So here is constant. Well, if they're traveling, what might be happening? If it's a constant distance, they're staying in the same place. So they must have pulled over to get gas or eat or something like that. They're not increasing their distance. Then here again, they're driving again. Their speed is going very fast here. Constant. If it is a car racing, they're getting their oils changed, their tires changed, all of that kind of stuff. If they're us as humans, we're getting our, I don't know, eating, drinking, going to the bathroom. And then here, if it's time and distance, it's decreasing. What would be happening? Maybe here, our distance is we are going back to our original starting location. So we're getting closer and closer to home, and we went straight home without any stops. So in the original piece, I gave you a example of driving to someplace and stopping for gas. Discuss another situation that might, as time goes, distance is changing. What other scenarios could you have? Pause the recording, have that discussion, and then do your first digital practice. Have a good day. I'll see you next time.